In this videotape, we're going to learn how to solve quadratic inequalities. And we're going to be using the techniques that we developed for solving quadratic equations. The technique is best explained by means of an example. So let's start. Example 1, we want to solve for x. X squared minus 4x minus 5 is less than 0. Okay, now we're going to begin by solving the equation. Begin by solving the equation x squared minus 4x minus 5 equals 0. First, I want to figure out when this quantity is equal to 0. That's going to help me determine when it's negative. Okay, to solve this, this is an easy one to solve by factoring. We're looking for two numbers which multiply to minus 5 and add to minus 4, and they are minus 5 and plus 1. And checking this by FOIL, x squared plus x minus 5x, that's minus 4x minus 5, giving us x minus 5 equals 0, x plus 1 equals 0, x equals 5, x equals minus 1 as the solutions here. Okay, now let's see what we've determined so far. We have a number line. Let's put these solutions down on the number line. Let's say this is 0, 1, 2, 3, 4, 5, and minus 1 is minus 1. Now we're interested in the value of x squared minus 4x minus 5. And we know it's equal to 0 here, and it's equal to 0 here. Okay, and we're interested in when x squared minus 4x minus 5 is negative. And we sort of think along these lines. We say that these two numbers, minus 1 and plus 5, have divided the number line up into three segments, say portion 1, portion 2, portion 3. Now, on these portions, 1, 2, and 3, x squared minus 4x minus 5 cannot change sign. It must be the same sign. Why? Because we know that in order to change sign from plus to minus, okay, we sort of feel that we should be passing through 0. This type of an expression, x squared minus 4x minus 5, okay, without getting into advanced mathematics and discussing why this is true, this sort of common sense tells us that if this is going to change sign from plus to minus, it would have to pass through 0 in between. Or if it's going to change sign from minus to plus, it should pass through 0 in between. So if the only times this takes on the value 0 is here and here, okay, then throughout portion 1, this must have the same value, the same sign. Okay, it must always either be positive or negative. On portion 2 also, it must always be positive or negative. And on portion 3, always positive or negative. It cannot change signs unless it's passing through 0. The only way to go from plus to minus or minus to plus is to pass through 0. So all we have to do is to evaluate this expression somewhere on each of these portions. In other words, any number less than minus 1 we could use, any number between minus 1 and 5, and any number greater than 5. Now, for example, if we evaluated at some number greater than 5, for example, 6, we substitute in here and we see that it comes out to be positive. Then not only do I know that it's positive at 6, it must be positive throughout the interval greater than 5. And similarly, if we pick a number between minus 1 and 5 and evaluate it, whatever the sign is between minus 1 and 5, at this testing point, it must be that same sign throughout the interval. Okay, so what we're going to do is to look at the places where it's 0, minus 1, 1, 2, 3, 4, 5. Here it's 0, and try to pick a value in each of these portions and evaluate x squared minus 4x minus 5 at that number. Okay, so we're going to start in the first portion here. I'll evaluate x squared minus 4x minus 5 at x equals minus 2. Anything less than minus 1 would have been acceptable. I could evaluate it at minus 99.5. Okay, but I want something simple. Okay. I'm also going to pick a value between minus 1 and 5. I will evaluate x squared minus 4x minus 5 at x equals anything between minus 1 and 5. Well, 0 is a simple value to evaluate at. And then finally here, I'm going to evaluate x squared minus 4x minus 5 at x equals, let's say, 6, anything greater than 5. Okay, doing this, we get at minus 2 squared minus 4 times minus 2 minus 5. We're substituting in x equals minus 2 into that expression. X squared minus 4x minus 5, and we get 4 plus 8 minus 5, 12 minus 5, or 7. Therefore, at minus 2, which is in this interval here, the expression x squared minus 4x minus 5 is positive. It's greater than 0. 7, it's greater than 0. Therefore, it must be positive throughout this whole first portion. So, x squared minus 4x minus 5 must be greater than 0 whenever x is less than minus 1. Since we pick the testing value in each portion, okay, at minus 2, we see that it's positive. Therefore, it must be positive throughout this whole first portion. Okay, the idea being is that if it were to switch from positive to negative, it would have to pass through a value where it's 0. But the only place it's 0 is at minus 1 and at 5. Okay, similarly, let's do the same thing. Here, x equals 0. We want to evaluate this expression. We'll get 0 squared minus 4 times 0 minus 5. And that just gives us minus 5, and that's less than 0. It's negative. Since x squared minus 4x minus 5 was less than 0 at a testing value in this interval, it must be less than 0 throughout the interval. That is, anytime you're between minus 1 and 5, x squared minus 4x minus 5 must take on the same sign as it did at 0. Therefore, it is negative throughout this second portion. It must stay negative. It's negative at 0. It must stay negative throughout, because to change to positive would imply it's passing through 0, and it's only 0 at minus 1 and 5. Finally, we evaluate x squared minus 4x minus 5 at x equals 6. 6 squared minus 4 times 6 minus 5. That's 36 minus 24 minus 5, which comes out to be 12 minus 5, or 7, and it's positive. So that tells us that x squared minus 4x minus 5, it's positive at the testing value in this portion, and therefore it's positive throughout that whole portion. Therefore, it's positive when x is greater than 5. Okay, now what was the original question? The question is, when is x squared minus 4x minus 5 less than 0? When is it negative? Okay, and the answer was, well, it was positive throughout the third portion. The answer is that it is only negative between minus 1 and 5. Okay, so our answer is x squared minus 4x minus 5 is less than 0 when x is between minus 1 and 5. Now, I said strictly between minus 1 and 5. We could not make this make these equalities or less than or equal signs, because at 5 and at minus 1, it's not less than 0. It's equal to 0. And when you're greater than 5, you're positive. When you're less than minus 1, you're positive. So the only answer here is strictly between minus 1 and 5. Now, if the original problem had been less than or equal to 0, you'd first work it out, find out when it's less than 0, and then include in those values for which it was equal to 0, namely minus 1 and plus 5. And then it would have been minus 1 less than or equal to x less than or equal to 5. Solve for x. 2x squared greater than or equal to 6x. Okay, first we're going to try to solve the corresponding equation. That is 2x squared equals 6x. Putting it into standard form, 2x squared minus 6x equals 0. There's a common factor of 2x, which can be taken out. This leaves us with 2x times x minus 3 is 0. So we have 2x equals 0, or x minus 3 equals 0, giving us x equals 0, x equals 3. That's when 2x squared equals 6x. Okay? By the way, this inequality is equivalent to this, 2x squared minus 6x greater than or equal to 0. So we want to solve for x, this inequality, which is equivalent to this. So the question is, when is 2x squared minus 6x greater than or equal to 0? We know where it's equal to 0. The question is now where it's greater than 0. So we make our number line, and we put in the values where it's equal to 0. Okay, it's equal to 0 at 0 and at 3. Okay, here it's 0, here it's 0. And the question is, what is the sign on each of these 3 portions? So we need a testing value in each of the portions. So we can evaluate 2x squared minus 6x at some value less than 0. Let's say at x equals minus 1. You could have used any value less than 0. And we get 2 times minus 1 squared minus 6 times minus 1, or 2 plus 6, which is 8, which is greater than 0. And if 2x squared minus 6x is positive at a testing value in this portion, it is positive throughout the portion. Okay, now we want to evaluate 2x squared minus 6x at something between 0 and 3. So let's say at x equals 1. And we get 2 times 1 squared minus 6 times 1. 2 minus 6, that's minus 4. And minus 4 is less than 0. Since at the testing value in this portion, in this interval, the expression came out negative, it must be negative throughout the entire interval. And finally, we want to evaluate 2x squared minus 6x at some value greater than 3. So, for example, we could check it at x equals 4. 2 times 4 squared minus 6 times 4. 4 squared, that's 16, times 2, 32, minus 24, comes out to be plus 8. It is positive. Since this expression is positive at the testing value, it is positive throughout the entire interval. Now let's understand the question. We know when 2x squared minus 6x is equal to 0, namely at 0 or 3. The question is, when is it positive? Well, 2x squared minus 6x is positive if x is less than 0 or if x is greater than 3 on either of these extremes. It was negative between 0 and 3. It was positive when x was less than 0 or when x is less than 0 or greater than 3. So that's where it's positive, when you're less than 0 or greater than 3. And that's where it's equal to 0. So the final answer is the following. Okay, we wanted to find out, we wanted just to remind you to solve for x, 2x squared greater than or equal to 6x, or 2x squared minus 6x greater than or equal to 0. We found out it was equal to 0 at 0 and 3, and it was positive when you were less than 0 or greater than 3. Okay, so your answer is all x greater than or equal to 3, or less than or equal to 0. We took the region where it was positive, that is less than 0 or greater than 3, anything in this region or in this, and added on the values where it was actually equal to 0. So greater than or equal to 3 or less than or equal to 0. If you wanted to graph the solution set on the number line, you'd have here 0, 1, 2, 3. Okay, we could do that in this form. Anything 3 and larger or 0 and smaller, using the filled-in circles to indicate that these endpoints are actually included. If it was just greater than 3, then I would have written it like this. That would mean 3 is not included, but everything to the right of it is. But since it was including the endpoints, we have it like that. Okay, in example 3, we want to solve for x. 12 minus x squared greater than x. Okay, now I'd like to put everything on one side and 0 on the other side. So let's say we bring everything over to the left. We get minus x squared minus x plus 12 is greater than 0. And then I prefer to start with the lead coefficient plus 1. So I'm going to multiply through by minus 1, and that'll give me x squared plus x minus 12 less than 0. Because if you multiply through by a negative sign, okay, you have to reverse the direction of the inequality. By the way, if you had decided to take the other approach, that is, get everything over on the right side, then we would have started with this. We would have said subtract 12 from both sides and add x squared to both sides. We would have had 0 greater than x squared plus x minus 12. And that, of course, is equivalent. If 0 is bigger than this, then x squared plus x minus 12 must be less than 0. So either way, we can put it sort of in standard form with lead coefficient of plus 1. We'll bring it over to either side, and then if necessary, multiply through by minus 1. So this is the question. Solve for x. Find out when this expression is negative. Okay, the first thing to do is to find out when it is equal to 0. Okay. When is x squared plus x minus 12 equal to 0? This also factors. It factors into x plus 4 times x minus 3. Looking for two numbers, multiply to minus 12 and add to plus 1. We check it, x squared minus 3x plus 4x, that's plus x minus 12. We have x plus 4 equals 0, x minus 3 equals 0, x equals minus 4, x equals plus 3. Okay, so as before, we're going to make our number line. We have this is 0, 1, 2, 3, and minus 1, 2, 3, 4. These are the values at which the expression x squared plus x minus 12 was equal to 0. We want to know x squared plus x minus 12. We're interested in the sign. You know, here it's 0 and here it's 0. And the question is, what happens in these portions? So we will evaluate it in each of these segments. Evaluate this at any value less than minus 4. So, I mean, you don't have to take minus 5. Okay, you don't have to take the next one. You could take minus 6. Anything will work. And you get minus 6 squared plus minus 6 minus 12. That is 36 minus 18. This is 36 minus 6 minus 12. That's minus 18. That's 18, and that's positive. Since this expression is positive, at minus 6, which is in this portion, it is positive throughout the portion. We now evaluate x squared plus x minus 12 at any value between minus 4 and 3, and of course 0 is a particularly simple one to do it at. We get 0 squared plus 0 minus 12, which is just minus 12. And that, of course, is negative. It's less than 0. So since this expression is negative at a testing value in this interval. It is negative throughout the interval. And then finally here we want to evaluate x squared plus x minus 12 at some testing value in this interval. Let's say x equals 4, anything greater than 3. You'd get 4 squared plus 4 minus 12. That's 16 plus 4 minus 12, 20 minus 12, which is 8, which is positive. And since this expression is positive at the testing value in this interval, it is positive throughout the interval. Okay, so now we know what happens to this expression as we go through the number line. The question was, when is this expression negative? So our answer is x squared plus x minus 12 is less than 0 when you are between minus 4 and 3, when x is between minus 4 and plus 3. For all x between minus 4 and 3, but not including the endpoints, because it just said when is it negative, not when is it 0. It is negative between these two values where it's 0. Example 4. Solve for x. X squared minus 6x plus 9 is greater than 0. Okay, our usual procedure. We want to know when is it equal to 0. So we say x squared minus 6x plus 9 equals 0. And this factors two numbers which multiply to plus 9 and add to minus 6. They are minus 3 and minus 3. And this gives us x equals 3 as the only solution. Okay, now, you proceed exactly the same way. We put 3 in on our number line, because we know at x equals 3, this expression takes on the value 0. You get 9 and 9, 18 minus 18 is 0. And we just need to test on either side of 3. So we pick some value less than 3. For example, let's evaluate x squared minus 6x plus 9 at x equals 0. That's some value less than 3. And we'll evaluate x squared minus 6x plus 9 at x equals 4. Some value greater than 3. Okay. When we do this, we get 0 squared minus 6 times 0 plus 9. And that's 9, and it's positive. Since this expression is positive at the testing value, it is positive throughout this entire interval. Now we go over here, and we evaluate this at x equals 4, and we get 4 squared minus 6 times 4 plus 9. That's 16 minus 24 plus 9. 16 plus 9, that's 25 minus 24, it's plus 1. And we have a value which is positive. Okay, so since this expression is positive at a testing value in this interval, it is positive throughout this interval. Okay, now this can happen. I mean, I know that in the other examples it changed from plus to minus. Okay, but this is still a possibility. The question is, when is this positive? And we see everywhere except at x equals 3. So the answer here is, when is this positive? When x is greater than 3 or when x is less than 3. Where it's all values except when x equals 3. Okay? When x equals 3, this takes on the value 0. Any other time, it has to be positive. So all x greater than 3 or less than 3. And one way of looking at this, to see this, is that x squared minus 6x plus 9 is really x minus 3 squared. And since this is a square, okay, we know that it can't take on any negative values. Okay? If 0 is squared, you'd get 0. If a negative or positive number is squared, it would come out positive. And this is exactly what we found out here. We found that at x equals 3, it's 0. But at any other value, okay, as long as x is not equal to 3, whether this is positive or negative squared, it comes out positive. So the question is, when is this positive? x greater than 3 or less than 3, just not equal to it. Okay, and for our last example, I want to do the following. Example 5. Solve for x squared plus 4 greater than 0. Okay, and as always, we start the same way. We try to figure out when this takes on the value 0. Okay, when we start doing this, we get x squared equals minus 4, and now we want to take the square root of a negative number. And we run into trouble here, and if we think about it, there is no value of x, so that can be squared will come out to be negative 4. If x were 0, okay, squared is 0. Positive or negative squared is going to come out to be positive. So the answer is there is no real x for which this is equal to 0. So what are we going to do about a testing value? Well, the answer is, since this expression never takes on the value 0, okay, so that it can't change sign from positive to negative or negative to positive, because that could only happen if you pass through 0, we can just simply think of this as just one big portion. In other words, we do not break up the line into portions. We simply evaluate this anywhere. Evaluate x squared plus 4 anywhere on the number line. For example, evaluate it when x equals 0, and you see you get 0 squared plus 4, and it's positive. Since x squared plus 4 is positive at a testing value of 0, it must be positive throughout. In other words, you pick any testing value, whatever the sign is at that testing value, that must be the sign for all real numbers. Because if it were to change, it would have to pass through 0. And this is never equal to 0. Okay, so any testing value will do. So the question is solve for x. When is this true? And the answer is all real numbers x. Or if you write a notation like this to be the entire real line, everything from minus infinity to plus infinity, to indicate all real numbers x. And that brings us to the end of this tape.